First of all, what is a radical function? Just like it sounds, it contains a radical expression with the independent variable in the radicand being the radical symbol. So you have a variable inside the radical, you have a radical function, all right? And they've given examples here. It does not just have to be a square root, which is really what I wanted you to see in this first example here. You see that you have a cubed root, all right? And you'll notice the cubed root graph looks actually like a cube, x cubed sideways, right? So if you think about an x cubed, the cubed root, which is the inverse there of x cubed, looks just like it, but sideways, which is what happens with inverses. They kind of flip across the y equals x line, all right, which is what's happened here. You'll notice when it is the fourth root, your domain changes, all right? So the domain here was really any x, negative infinity to positive infinity. But when it went to a fourth root, my domain changed. Why would that happen? Why would my domain all of a sudden stop right here? Yeah, positive. So if I have a cubed root, I can have a negative under that radical. Not a problem, right? But if I have an even root, this is why that radical function looks like that, okay? And so we only graphed the square root where it looked like this, but a little bit thicker, right? He looked a little bit fatter. But any even root is going to have a domain that looks like that. And even odd root is going to have one that looks like the one on the left there. All right. If you talk about graphing transformations, we've already done this. Same thing applies no matter what the root is. They actually used a square root here. This is the same thing as +4, by the way, on the other side. You'll notice they put a negative in front and added the 4 to the end. So even if it's in front, it's still the guy on the outside. This flipped it, right? So it went from going up to going down. This moved it left 3, up 4. And so you see that it's over here. We've already done this. I just wanted to show you that we're moving into dealing with radical functions. We've already dealt with the graphs of them. And then the third example is inverse. And again, we have found the inverse. It doesn't matter if it's an inverse for a radical or not. You do the same thing. You are going to switch your x and y values. You're going to solve for y. So in this case, they had to get rid of the radical. They squared it. They added the 1 over. Here is my inverse. So you treat it exactly the same. Doesn't matter if there's a radical in it or not. You're still going to switch x and y, solve for y, right? So the first 3 examples we really did in the last chapter. What we're going to spend the majority of our time on for this section is solving radical equations, all right? Solving radical equations. So let's look at page 74, example 4. The first thing we have here is a basic radical equation. When they say solve it, they actually want you to figure out what x is. What is x here? So when they say solve, they want you to find x. The key to doing this is to first get that radical by itself. So we are going to move the 1 over. We will subtract 1 from both sides. You have your radical here, x plus 5 on the left. You have x minus 1 on the right. To get rid of a radical, you have to raise it to the power of the index. So what is the index of this radical? When you don't see an index, what is it? 2. It is 2. So I have to raise both sides to the second power here to get rid of that radical. So when my index is 2, I have to raise it to the second power. Now on the left-hand side, when I raise it, it actually just gets rid of the radical altogether. All right, and we're going to see that a little bit more when we deal with fractions. But it gets rid of the radical. When you raise a radical to its power, the radical goes away. So I'm literally left with just the x plus 5. On the right, just a quick review. How would one do that? It's definitely not x squared plus 1. No. What do we need to do here if we have a group that is squared? Yeah, it's foiled, right? So you're technically doing this right here. All right, so you end up with x squared minus 2x plus 1 right there, okay? Now, right at this point, we are legit just solving a quadratic, okay? So think about your rules for solving. I'm going to move all my x's to one side. set this equal to 0. If this were just x to the first power, I would move x's to one side, variables to the numbers to the other, and divide, right? But it's a quadratic, so I'm going to move everything to one side and set it equal to 0, and then I'm either going to solve by factoring our quadratic formula, okay? So I'm going to move the x over, and I'm going to move the 5 over. Anytime I move something for a quadratic, I try to keep my leading coefficient positive. You have more factoring issues when your leading coefficient is negative. People just tend to do that incorrectly. So subtract your x, subtract your 5 here. On this side, you have 0, which is what you want. You have x squared minus 3x minus 4. This is a simple factoring, right? Factors of 4 that subtract to give you 3. What are those? Yeah, so you're going to have a minus 4 and a plus 1, right? And then to finish that solving, set each one of those equal to 0. You're going to say x is going to equal either 4 or negative 1. Now, here's the thing with radicals. Like anything else, when you have a limitation potentially on your domain, you have to check for extraneous solutions, right? What would be my limitation here? Can't have a negative in the radical. Also, when you plug things back in, you're doing order of operations, and so the square root will be positive. Okay, so when you have a variable involved, like x squared equals 9, x could be positive 3 or negative 3. But when I say the square root of 9, that is 3. Straight up order of operations, everything's a number, right? It is not negative 3. You are talking about the primary root when you just have numbers. So you have to actually check for both of those things. Does it actually work? Does it give me an answer that works? And does it give me an actual answer to a square root, right? And so when I have 4 and negative 1 here, I really need to go back up here and say, do both of those work? So I need to plug in my 4 into both parts, right, of that x. And I need to do the same thing with negative 1. All right. And so then I'm going to just do the process. 4 plus 5 is 9. Square root of 9 plus 1 equals 4. Square root of 9 is 3. 3 plus 1 equals 4. Yes, that is true. All right. Do the same thing over here. Negative 1 plus 5 is 4. Square root of 4 is 2. 2 plus 1 equals negative 1. That is not true. We have an extraneous solution. All right, so I got a false statement here. He is not a solution. That means x equals 4 is your only solution. Negative 1 was extraneous. It did not work when I plugged it back in. All right, so when you look at this one right here, technically, if you'll recall, 2/3 is a radical, right? It's the cubed root of x squared, all right? So you could rewrite it that way if you wanted to. Oftentimes, it's easiest to leave it as a fractional exponent. And so there are times when leaving it as a fractional exponent actually works to your advantage. In this case, the x to the 2/3 is kind of almost by itself. You just move that 1 over. So your goal here is still to get it by itself. We're going to take this, and we want to get that by itself. We're going to add that 1 over. And when we do that, that will cancel. We have x to the 2/3 equals 16. All right. When you try to get rid of a fraction, think about what you do when you're moving it from one side to the other. To get rid of it, you multiply by the reciprocal, right? Multiplying a fraction by its reciprocal turns it to 1. Technically, you want to get this x to the power of 1, which means I want to raise this to the 3/2. Okay, I want to raise it to the reciprocal. So I'm going to take this and I'm going to say, well, if I raise it to the 3/2, remember a power to a power is just multiplying. So if I raise it to the reciprocal of whatever it is, I'm going to get the x by itself. However, if I do that to the left side of this equation, I must do it to the right side of the equation. All right. Now, the thing here is most people don't look at 3/2 as a power to anything you can do with. So they show you to do it another way than I'm going to show you to do it. Okay. They actually tell you to rewrite the 16 as 4 squared and then multiply the 2 and the 3/2. But a lot of people aren't going to recognize that they have a base and a power that's similar. So at this point, you can rewrite it as a radical. Okay. Rewrite it as a radical. What do I mean by that? Well, the left side's still an x. This is going to be 16 as a radical. The bottom number is my index. So I'm talking about the square root, right? The top number is my exponent. So I'm going to say to the 3rd power, right? This makes more sense in our brains, doesn't it? Instead of 16 to the 3/2, I know that square root of 16 means something. 16 to the 3/2 doesn't really mean anything to me, okay? And so now I can just process that. What is the square root of 16? Well, that's 4. And then what is 4 cubed? Well, that is 64. All right. Now, the only thing you have to remember here is I am taking the square root with a variable involved. So what is the square root of 16? Positive or negative 4 to that power. That matters when my numerator is odd, when my power is odd, because what is that going to do to my answer? Positive or negative 64. Okay? So you have to consider the positive and negative when you do this root. And you would have to do it even if you did the other way, because the other way that they did it, they did absolute value of x equals this. And I don't think people are going to think to do this. But when you do a radical with a variable involved, not when you're checking your answers, that's just order of operations. At this point, we're still solving and we're saying x equals the square root of 16. Well, that could be positive 4 or negative 4. And then take positive 4 to the 3rd power, positive 64. Negative 4 to the 3rd power, negative 64. So my answer here is positive or negative 64. And if you plug it back in, the cubed root of negative 64 is negative 4 squared, right? 16 minus 1. The cubed root of positive 64 is positive 4 squared. 16 minus 1 is 15. They both work, all right? So when you check these, they will both work.